Hi again. In this lecture we will discuss about different types of cross sections that we can use for the members in a truss when we design them. Specifically, we will talk about custom sections versus rolled sections. Let's start first with custom sections. And when I say custom sections, what that means is any simple section shape. So let's see a few very simple examples. A square, solid square section could be a custom section. A rectangular solid section is also a custom section. As would be, say, a round solid section, like this one with a diameter D, or a triangular section, for example, solid triangular section. What is generally common to all these sections? They're simple sections. We can easily calculate their properties, in other words, their cross-sectional area, and based on the density of the material, their mass, like for example the mass per unit length of the member, and so forth. They are custom because they're not readily available, so we need to specify them, and somebody has to manufacture them to order, and therefore they're called custom sections, so they need to be custom order really. The second type of sections, let's call them rolled sections, and you'll see shortly why they're called rolled sections. And as an example, for trusses, for the members in a truss, we will look at what is called equal leg angles. The cross section of an equal leg angle looks like this. It's kind of like the letter L, but if you look carefully, this L is not made of two rectangular areas, because these areas have rounded corners, as if you can see if you look carefully. The two portions of the cross section are called legs, and of course the cross section is defined by a wall thickness. The rounded edges, as you will see, will make it more difficult to calculate the properties by hand, such as the cross-sectional area. These sections are termed rolled due to the manufacturing process. So they are created through a process that is called rolling, in which very hot, almost molten steel is passed through these metal, very strong metal wheels, and these wheels will compress through rolling the soft metal until it reaches the final shape, which is the angle. Again, this process is called rolling, and hence these sections are rolled sections due to the manufacturing process. Now, the problem with these sections is because of those rounded corners, it is not that easy to determine their cross-sectional areas and their mass. But these numbers are tabulated, so somebody else has gone through the pain of calculating the properties exactly and listed these numbers in a table. So therefore, do not attempt to calculate these properties, because you will never be correct, you'll never be exact, again, because of these rounded corners. So you'd have to go to the table and get the properties from the tables. The other characteristic of the roll sections, they're already pre-manufactured, they're readily available. So once you specify them in a design, all you have to do is order them from a manufacturer, from a rolling plant. Now this is a typical table which is also contained in full in the complementary notes, but this is a typical table which indicates the properties of equal leg angles, for example. What is important to us is the size, which is actually the leg size, so indicates how long the leg, each leg is, but they're both equal. The wall thickness, and of course the mass, which is given in kilograms per meter, the mass per unit length. Remember, we need to select the lightest members that are still strong enough for our design, and we ensure that by selecting a member with a sufficiently large cross-sectional area, larger than what we require. So in purple I have highlighted here a typical section. The leg sizes are 150 millimeters each, and the wall thickness is 13 millimeters, and the section like this is designated with a letter L in front of the numbers. That means it is an angle followed by the leg sizes and the wall thickness. This is how the final answer of a design should look like. L 150 by 150 by 13. Now, having said that and learning about different types of cross sections, thank you for watching this lecture, and we will do a few examples in the next one.